Here we go. This is method 3, using decimals to order fractions and decimals. This is a method that I think is the best if you have a list where it has a lot of decimals in it and not very many fractions, or if you have a list of fractions that don't have easily made common denominators. I'll show a list like that right now. Here's that list: 6 decimal 3, and then you've got 20 over 3, you've got 6 and a third, you've got 6 and 4/5, and 6 and 3/7. Notice these are different denominators. If you wanted to use method 2, what you could do is for each of these fractions, you would multiply by the top, the numerator, and the bottom, the denominator, by the other denominators. So this, you'd multiply top and bottom by 5, and then you do top and bottom by 3. Then this one, you go top and bottom by 7, numerator and denominator by 3. And this one, you do it by 5 and by 7. This one would be by 5 and by 7. That would, and then you'd change this into a fraction. As you can hear in all of that, it would take quite a while. So I'm going to use decimals for this one, even though there are more fractions. So this first one, it's already a decimal, so I'm going to carry it down. I'll figure out how far I need to in a bit. 20 over 3, or 20 thirds. I need to do that potentially through long division, or I can maybe convert to a mixed fraction and realize maybe there's some fractions that I've memorized. I'm going to show the long division here. I put 20 inside because it's dividing by 3. 3 goes into 20 6 times. It makes 18. Subtract 18, 2. Now where it ends, I can put a decimal in there and put a 0 in because there's 0 in the 10th spot, and bring that down. 3 goes into 20 6 times. Not 3, 6 times. 3 times 6 is 18. Oh, it's that same pattern. It's the same number again. Bring it down, go 6 times, got 18. Okay, once we got this repeating pattern, we know that this has to be 6 decimal 6 repeating. That's how far I'm going to bring it down. So this one was 6 decimal 3. Okay, next we've got 6 and a third. So we can actually just take this part here and we can divide. So put 3 and put a 1. 3 goes into 1, 0 times, bring it down. 0 times 3 is 0. It's a 1. Put our decimals in, bring down a 0. 3 goes into there 3 times. Guess what? You probably already knew that a third was 0 decimal 3 repeated, right? But just to show that, this is just going to keep repeating. Once it repeats a couple times, it should be obvious. It's 3, 3, 3 over and over. It's not going to leave this pattern. So what is our decimal? It's decimal 3 repeating, but we had a 6 in front, so it's not 0 decimal 3, it's 6 decimal 3. So this in front, we just throw in where that 0 would have been from the fraction. For this one, we could do 4 divided by 5 with long division, or probably a quicker way is we know we can multiply this by 2 and end up with 6 and 8 tenths, which means we have 6 and then an 8 in the 10th spot. Finally, this last one, it involves doing long division, which can take a while. I'm going to show you that piece of paper that I did this long division on. It's a pretty long problem. I have to move it down. You'll notice that I did 7 goes into 3 0 times, brought it down. This is a 3. Added my decimals in, brought a 0 down. And then it went in 4 times. 4 times 7 is 28. Subtract, I get 2. Take my 0, bring it down. 20, 7 goes into 22 times. 14, so forth. And eventually I got to a part where it went 4, 2, 8, 5, 7, 1. And then again, 4, 2, 8, 5, 7, 1. So I knew that this was 0 decimal 4, 2, 8, 5, 7, 1 repeated. But looking at my answers here, I have 6 decimal 3, I have 6 decimal 6 repeated, 6 decimal 3 repeated, 6 decimal 8. Right off the start, when I got to my decimal 4, I already knew that 4 was bigger than 3 and it was less than 6, which were the next ones. So already I knew this one would have to be in between there. So sticking this in, I know it's 2.428571, but it didn't say that I had to figure out the exact decimals in this case. I didn't have to do that whole long division. All I needed to see was the 6.4 part right here, and I would have known where it fit in this list. So now our second last step is to just organize these so that you have them from, forgot to write this in here, we are going to do least to greatest. Sometimes it'll be the opposite, so always check. This is going to be least to greatest. So find the least. All of them are 6 decimal something, so we can't look at the units place. We need to look at the next one, which is the tenths, and which is the least one. We've got 3 in the 10th spot. Remember, 6.3 repeated is 6.333, and it keeps repeating over and over, which means this has more in its 100th spot than this one does. So 6.3 would be our least, and then 6.3 repeated would be our next one. Then it's our one with 6.4, so 6.428571. Next, looking at our spot, we have a 6 and an 8. It's going to be the one with 6, so 6.6 repeated, and then 6.8. And just like in method 2, our final step is to change these back into their original forms. So 6.3 originally was just 6.3. 6.3 repeated, find that, it's right here, was 6 1/3. 6.4, blah, blah, blah. 6.4 was the 6 3/7. 6 3/7. Our 6.6 repeating was 20/3, 20/3. And 6.8 was right here, was our 6 4/5. So just to go through the steps again, first we change these fractions into decimals by long division is one way, or by using some patterns we know. If any of them can go to a denominator that is a 10 or even to a 9, because you know some patterns with 9s, you could do that. These I could have done a different way by realizing that this could have been turned into 3/9, and 3/9 we know is 3 repeated, which is how we got 3 repeated. Or maybe do long division for a little bit and realize that 6.4 would fit between these. If there were some here that had decimal 4s, we'd have to go further. So this would be to change to decimals. That's our first step. Next would be to order them by place value. And finally, same as the other one, it would be putting them back in their original form.